अच्छा, so you had optical isomers, which are non-superimposable mirror images of each other. Okay, your hands are two examples, and whatever you do, okay, your left hand is going to look different, and it's going to point something on your left hand would point in a different direction compared to your right hand. Okay, no matter how you rotate your left hand, it's something either your fingers or your palm or your thumb. It's going to point in a different direction compared to your right hand. Okay, no matter what you do. So that is what optical isomers are. And optical isomers are formed around a chiral center. Okay, so there's this carbon atom. What's a chiral center? It's a carbon atom that's which is sp3 hybridized and bonded to four different groups. Now this is very important. It's bonded to four different groups. So optical isomers, chiral centers. So I'm going to draw a chiral center. I'm going to show you how optical isomerism happens. There's going to be carbon atom. It's going to be tetrahedral. Why? Because it's sp3 hybridized. It's bonded to four different groups, making four single bonds. So that's like your pyramid with one bond on top. And let's say there is a CH3 at the top, and there's an H at the top, and OH over here, and let's say all four must be different. And there's a Cl over here. So that's a chiral. This carbon atom over here is called a chiral. It's called a chiral center because it's capable of forming non-superimposable mirror images. Basically, what's going to happen is that there's going to be another molecule that's going to look exactly the same. TK, it's TK like your left hand and your right hand. So there's going to be another molecule, a different molecule that looks exactly the same, except that it's the mirrored version of the first one. So one bond over here. So I'm going to draw, and you'll be asked to draw mirrored versions. So this bond would be over here. TK, properly mirror the molecule. So I think I've properly mirrored the molecule. The bond that was coming on the right, what does the mirror do? It changes the left and right. It switches the left and right. So this is your mirrored version. So the OH which was pointing to the right is now going to be pointing to the left. So the OH is over here. The H which was pointing to the left is now pointing to the right. The CH3 stays at the top, and here's your Cl. Okay, so this is your mirrored version of this. So it's a different molecule, a completely different molecule, which is a mirrored version of the first one. Now what happens is just like your hand, no matter what you do, no matter which way you rotate this molecule is never going to look exactly like this. One of the bonds is going to be pointing in a different direction. Okay, for example, this Cl is coming out of the page towards you. Okay, it's like the part of the pyramid that's pointing towards you. If you try and rotate, like if you pick it from the top and you try to rotate the OH and bring it to the right, the OH would start pointing to the right. So if you start rotating it, okay, let me show it. If you start rotating it, the OH would start pointing to the right, and the H would start pointing to the left. So the OH and H would switch positions, and they would start looking like this. The OH would come to the right, and the H would come to the left. But the Cl, which is right now pointing towards you, would start pointing into the board on the other side, and that bond would be in a different direction compared to this one. Is this point clear, Ibrahim Basra? Is this clear? Abba, is this clear?
Yes, sir.
Rida, Hiba, is this clear? Minayan?
Yes, sir.
Sir, can you explain the meaning of this term non-superimposable again? Because my internet kind of went out.
Nee, I'm just going to show you what. Okay, maybe you'll get a. What were they called? Optical isomers. Just a second. Acha, what I wanted to non-superimposable is that when well, there must be a Acha, what happened? What I told you was that your two hands are non-superimposable. Okay, what that basically means is, okay, you pick your right hand, start rotating it any way you like. Okay, turning it upside down, whatever. It's never going to look like your left hand. Okay, its fingers, its palm, it's your if it's your thumb, one of the things is going to be pointing always in the wrong direction. Okay, so that's non-superimposable. That this is like a chiral molecule. No matter what you do to this one, it's never going to look like this one. Okay, because if I try to get this red ball over here on the other side, this yellow one would start pointing behind. It's going to go behind. So no matter how I rotate this, one of the bonds is not going to align and it's not going to look like this. Okay, Bazga, is this clear?
Clear.
Achha, so just for simplicity, what you just need to know is that you're going to look for the chiral center. You're going to look for the molecule or the carbon atom that's sp3 hybridized, making four single bonds, and it's bonded to four different groups. That's pretty much it. If you find this carbon atom, that means there would be two versions of that carbon atom. There's going to be two mirror images of that carbon atom. That carbon atom could exist in two different ways. Together, this is called these are called enantiomers. Uh, these are called enantiomers. Okay, optical isomers. Basically, optical isomers are called enantiomers. So I'm just going to write that over there. They're known as enantiomers, and a mixture of both enantiomers. So a mixture of both enantiomers is known as a race mate mixture. It's known as a race mate mixture. Okay, so whenever you hear the term race mate, that means there's going to be a mixture that contains both enantiomers. Okay, enantiomers is a different name given to optical isomers, and this is very important in biology, in medicine. Uh, Biological molecules are very shape specific. One of them is going to work, the other one is probably not going to work, which is why you have a lot of side effects. Medicine has a lot of side effects because the problem is that if you're designing a drug molecule and you want this one, and by default, you're going to get some of these as well. TK, when you're trying to synthesize drug molecules, one of them is going to have good effects. TK, like the vaccines that you're getting, TK, they have side effects. The same problem is so it's a very complicated problem which needs to be solved. Uh, it's still unsolved to quite an extent. TK, it's very hard to get the right carbon shape. Like it's basically if you're trying to make a right hand, you make a left hand. That's what the issue is. Nature does it very well. Okay, the human body does it very well. Every amino acid is chiral. They're going to exist, and I'm going to draw an amino acid. Okay, every amino acid, it looks like this. That an amino acid has an amine group, it's NH2, and it has a carboxylic acid group, it has an H, and it has a carboxylic acid group, and it has some R group attached to it, which could be different in different amino acids. So this carbon atom is by default chiral. It's going to exist in two forms. Every amino acid is going to exist in two forms. So imagine the whole human body is built up of these tiny amino acid, and if you get one amino acid wrong, the whole structure collapses. For example, if the H is supposed to point this way and the H starts pointing this way, okay, and the left and right get switched, the entire structure, every cell structure, your skin structure, your hair structure, every structure it's going to be built incorrectly. So nature does it very well. It's capable of handling these uh, different chiral versions of molecules, but it's very hard to actually synthesize molecules in a laboratory of only one type. Okay, one type works, the other one doesn't work. Acha, so is this clear? Optical isomers.
Yes.
Yes.
Chalo. And there's one more thing. How do you differentiate them? Okay, I'm not going to go into the details of uh, how they are different. They're very identical. They almost have the same physical properties as well. Uh, but especially in biology, when you're making a complicated structure and you had to go left, it's like making a building. Okay, if you want to make a wall on the left side and you start making a wall on the right side, the whole structure is going to look different. So what's the difference between enantiomers? There's not much of a difference, uh, except when you have very complicated molecules. So the difference that you can have is that both enantiomers rotate plane polarized monochromatic light so plane polarized monochromatic light in different directions. And this was rotate. So they rotate plane polarized monochromatic light in different directions. So basically you can identify them by just shining a light on them, ठीक है, and you can look at the polarization of the light, ठीक है, which is a physics concept. One would rotate it clockwise, the other one would rotate it anti-clockwise. And usually one of them is represented by a plus sign, which means clockwise. The other one is represented by a minus sign, which means that it's going to rotate the light anti-clockwise. You would not be able to identify by just looking at the molecule which one is going to do that, which one is the plus and which one is the minus. Okay, so I mean over here I've just arbitrarily assigned the plus and the minus, uh, so that would either be given to you, but you would not be able to figure that out on your own. I said, so we're going to start doing questions, but let me do one example for this. Let's say I have a molecule, and the questions are going to be like this. Let's say there's this molecule, and there's H and H, and there's Cl. So can anyone tell me which one is the chiral center? Are there any carbons that would be existing in two forms? Can you spot any carbon atoms that which are chiral, bonded to four different groups?
No.
Let's start with the first one. Is this chiral?
No.
Okay, because it's bonded to. What about the second one? Is this chiral?
Nope.
Anyone else? Is this chiral or not? Baza, can you?
Yes, sir, this is correct.
No.
Okay, this is
Sir,
chiral
this
because
is
okay, look at the groups. On one side there's H, on one side there's Cl. On this side, this entire thing is attached, right?
Oh yes. Okay. Okay.
So on this side, it's this one. So this carbon atom, its three-dimensional shape, there would be two different versions of this. Okay, so this is chiral, and you can be asked to draw this. So there's going to be draw a tetrahedral diagram. So on one side there's an H, and on one side there's a Cl. This side there's a CH3 group, and over here you have CH, and there's a CH3 branch, and then there's CH2 and Cl. Right? This thing is dashed. And there's going to be a mirrored version of this where the left and right, I mean, the whole molecule would be mirrored. So this carbon would be existing in two versions. One would be plus, that rotates the plane polarized monochromatic light clockwise. The other one would be minus. Okay, so two different versions. Now, apart from this, I'm going to rub this. Is this clear, Rida, Hiba, Abba, Minahil?
Yes, sir.
So,
Yeah.
so now ignore that one. Balki most of the time you mark it with a nest with this thing. So, which other carbon atom is chiral?
The one next to it on the right.
Okay, so the one next to it on the right is also chiral because it's also bonded to four different groups. This thing over here, this thing over here, this over here, and this whole thing on this side. So that is also chiral. So you have two chiral centers, and that carbon would also have two different arrangements. So in total, the next part is exactly the same. We did this in alkenes. So how many different, if you have two chirals, how many different three-dimensional structures would this molecule have? Anyone, Ibrar? Any idea?
So can you repeat your question?
Like if you have,
Nisa, can you repeat your question?
I mean, if you have two chiral carbon atoms, okay,
Hmm.
first one, okay, Rida, that's correct. Okay, it's going to be four. Ibrar, what I was saying was that if you have two chiral carbon atoms, the first one is going to be, I mean, there would be two forms of this, right? Like mirrored versions of each other. This carbon atom is also chiral, so the
Hmm.
three-dimensional shape around this carbon atom, there would be two versions of it. One would be plus and the other one would be minus, right? So in total, how many
Ji.
combinations do you have? Well, this carbon atom could be there could be two mirrored versions of this, and this one could also have two mirrored versions of each other. So in total, it's going to be four. It's either both of them are the plus version, or the first one is plus and the second one is minus, or the first one is minus and the second one is plus, or both of them are minus. Is that clear?
Sir, I still don't. No, sir. I still don't get what you're trying to say.
But what happened in alkenes? Like if you go back to alkenes and we did the whole cis trans thing. ठीक है, what was going on over there? Okay, the first one, ठीक है, look at the screen. The first one. I mean, if a molecule had two double bonds and both of them, I mean, this could exist in cis and trans version, and this could also exist in cis and trans version. ठीक है? So how many different combinations did you have?
4.
ठीक है? Why? Because there was you could either have it in trans version, or the H could be pointing upwards and the CH3 could be pointing downwards, so that could be a cis version, right? Do you get the point? So in total, you had four. तो यहाँ पे भी तो वही हो रहा है ना कि you have an optical,
Hmm.
अच्छा, you have optical isomers now. I mean, this carbon atom could exist in how many
Hmm.
different arrangements? But two different arrangements, and mirrored versions of each other, right? I mean, the carbon atom, if it's
नहीं
chiral,
मतलब.
it could either be in this
Hmm.
form or it could be a mirrored version of this, of the same thing.
अच्छा अच्छा yes. हाँ ठीक.
Okay. So, but this is not the three-dimensional shape. This molecule over here is not the three-dimensional shape. But if you, I mean, it would be impossible to actually draw the three-dimensional shape because it would be too complicated. Tetrahedral connected to another tetrahedral and another tetrahedral, okay? But this tetrahedral arrangement would have two forms, and both of them would be mirrored versions of each other. So one would be plus and the other one would be minus. And this carbon atom would also have a tetrahedral arrangement, a three-dimensional shape, and one of them would be plus and the other one would be minus. There would be mirrored versions of each other. So in total, you have how many combinations? Four combinations.
4 combination. Yeah. Yes.
Okay, so you have four combinations. And the 2 to the power n formula also applies over here. Okay, 2 to the power n is where n is the number of chiral this time. In the previous case, we had n as the number of double bonds that were forming cis and trans. Now we have n as the number of chiral carbons. ठीक है? Is this clear? Minal, is this clear? Fazia, clear? Heba, is this clear?
Yes, clear.
Achha, so now we're going to move towards the worksheet. ठीक है? Just a second. I think I sent you the worksheet as well in the group. Maybe it's ठीक है, it was this one. As I remember, organic chemistry questions would be the most time-consuming questions. Starting with the first one, what is the total number of different? Now he's saying what is the total number of different chloroethanes with the formula C2H6 minus N and CLN that could be found where N can be any integer from
So
1
it
to 2.
wasn't this one. So it wasn't this one. क्या आपने share नहीं किया?
No, I haven't shared this one. No, I think I've shared this one.
No, sir.
नहीं, चलो ठीक है,
It
I'll share.
was.
नहीं, I was supposed to share this one then. ठीक है. I just starting with this one.
अच्छा.
What I'm going to
ठीक.
do is let's do this question over here. What he's saying is, okay, let's start doing questions. What he's saying is that there is a thing called C2, a chloroethane. Okay, and he was saying that it was H6 minus N and CLN. And Cl was N. And remember, he had stated that it was a chloroethane. And he had also stated that N had a value of 1 to 6. Starting with the first one. Now it's a 1 mark question, and it's a very time consuming question because you would have to draw at least I mean, like, even if you have to draw 6 isomers, that's going to take a very long time. uh, so starting with the first one, and there are no shortcuts. If N is 1, so it's going to be C2, H would become 5, and Cl would be 1. So basically there's going to be just one version. Like there's one Cl and there would be 5 hydrogens. Can you make an isomer out of this? Would there be another version of this?
No.
ठीक है, क्योंकि wherever you put it, it's just going to be a reflected version of that. Cl would still be attached to carbon position number 1. Let's do the next one. N is equal to 2. Okay, this is N is equal to 1. Now N is equal to 2. N is equal to 2 is C2H4. And Cl2. Now C2H4 and Cl2. So there would be one carbon atom and there would be 2 Cls now. Achha, can there be another isomer of this?
Yes, we can attach the Cl on the other carbon.
Okay, so you could have a Cl on this carbon atom and a Cl on this carbon atom. Okay, and no more. I mean, if you put the 2 Cls on the left carbon atom, it's going to be the same molecule. Let's do N is equal to 3, so it's going to be C2. H would become 3 and Cl would also become 3. So now you could have, how many versions could you have? You could either have all the Cls on, I'm not going to draw the H. Okay, these are H's. So that's one version. What would be the other version? That you can have 2 Cls here and 1 Cl at the other side, right? Then you can have N is equal to 4. That means it would become C2. 6 minus N would be, there would be 2 hydrogens left and there would be 4 Cls. Now, if you have 4 Cls, the Cls would either be 3 on one side, 1 on the other side, and they are hydrogens. Or you could have 2 Cls and 2 Cls over here, right? And similarly, if you have N is equal to 5, that means 5 Cls. So just a single version. And then you have another one which is with 6 Cl, n is equal to 1 to 6. So that's all of them would be Cls, right? So in total, how many isomers do you have? So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that is going to be your answer. It's going to be 9. ठीक है? Is this clear? Abba, is this clear? Minahil, clear है?
Yes.
Clear.
So next one is which compound on reaction. I mean, forget this. This is a reaction. We haven't done that. Which compounds have the same? Let's do only isomerism questions. Here's camphor. He's saying how many chiral centers are present in one molecule of camphor. So starting with the first one, is this chiral or not?
No.
ठीक है. This is not chiral because it's bonded to 3 hydrogens. There should be 4 different groups. Is this chiral? This one over here.
Yes.
ठीक है. This one is chiral
Yes.
because the top is different, the left side is different, the right side looks different, and the bottom side also looks. All 4 sides they look different. ठीक है. So this one is definitely chiral. So I'm going to put a star on it. This one is chiral. What about this one? This one over here. Is it chiral?
No.
ठीक है. 2 hydrogens. This one is also not chiral. 2 hydrogens. ठीक है. Uh, CH3 definitely not chiral. CH3 not chiral. CH2 not chiral. What about the C in the center? Is this chiral?
No, sir.
No.
क्योंकि both sides are the same. ठीक है. Hiba, Rida, is this clear? Abba, is this clear?
Yeah.
Acha, what about the serial bond? Oh, that's definitely not chiral because acha, that's definitely not chiral because it's a double bond. ठीक है. You needed a tetrahedral 4 single bonds. What about this carbon atom over here? The one at the bottom. Is this chiral or not?
No.
Acha, why is it not chiral?
CH2 on both sides.
Sir, it is.
ठीक है. It is actually chiral. There's an H over here. Uh, so one of the sides is definitely different. This side is different. There's something totally different on this side. I said, remember, don't look at the immediate neighborhood. Look at the entire side. Is this different compared to this one?
Yeah, okay, it's chiral.
Okay, so all 4 sides are different. So you don't actually just look at the immediate neighborhood. I mean, look at the whole thing. Is that different? If this would have been a CH2 as well, then this side and this side would be exactly the same. So how many chiral? You have 2 chirals in this molecule. So let's move on. Uh, he's saying which compound is chiral and both acidic. Acidic is carboxylic acid. So I mean, this is acidic. This is not acidic. I mean, basically, it's better to focus on this. I mean, this is an H. Is this chiral?
No, sir.
No.
Why is it not chiral?
Because of a double bond.
Okay, carbon is making a double bond. What about this carbon atom over here?
No.
Okay, that is also making a double bond because carboxylic acid group is double bond O and OH. Okay, so this a carboxylic acid group is also making a double bond, right? Ignore these two. Can you spot a chiral center in this molecule? I mean, it is acidic, but is it chiral? कोई idea? Abba, any idea? Rida, Minahil, any idea?
I think the first one.
Okay, because if you draw carefully, there's a C with an H and then there's an OH branch and it's connected to a carboxylic acid group. Okay, so this one over here, C.
Also, because the rest have either O2 attached to them or H2 attached to them, so they cannot be chirals.
Okay, but we were looking for. I mean, this is CH2, and then there's C double bond O and OH, right? So this is definitely not chiral, not chiral, okay, because it's double bond. This one is chiral. All four sides are different. There's a carboxylic acid. I mean, on one side you have this thing. On one side you have this thing. On one side you have H, and on the other side you have OH. So this carbon atom over here, this one over here is chiral. This one is definitely not chiral because it has two hydrogens, okay? So let's move to this one. Okay, how many chiral centers does each acid possess? I mean, just for clarity, I'm going to draw all of them. Okay, so how many chiral centers? Let's draw this one. C, there's H, and there's C double bond O and OH, right? Then there's at the bottom there's C, and then there's OH, and on the other side there's again C double bond O, OH. Let's focus on this one. It's again C, H, and C double bond O and OH. अब मुझे बताओ कि which carbon atom is chiral?
Sir, the middle part of it.
I said this one. You're saying this one is chiral.
Yes. No, this is not chiral. This is not chiral. No, it's not.
It's not chiral because this side is different. This side is different. But the top and the bottom are exactly the same. So it's not going to have this mirror image thing. It's not going to be chiral. Okay, Baki, the rest are automatically disqualified because this is two hydrogens, so that's not chiral. Two hydrogens, not chiral. Making a double bond, that's definitely not chiral. Double bond, not chiral. Okay. Hira, Riba, Aba, is this clear? Minahil, is this clear?
Yes.
Yes.
Acha, what about this other one, CH2 and C double bond O and OH, and the bottom is C and then H, and then you have C double bond O and OH, and at the bottom there's C and H and OH, and again C double bond O. So how many chiral centers does this have?
2.
2.
Okay. This is not chiral, this is not chiral, this one is chiral now. Because the top and the bottom are now different. The bottom now has an extra OH, so that's different. Plus, this one is also chiral because this side is different, this side is different, this side is different, and this entire thing is different. So there are two chirals in this molecule. Ignore this. I said this one. How many alcohols? Try sending the answer to me. Take a snapshot, or I'm going to just send this picture. I'm going to send this worksheet actually. So there's an alcohol. Remember, so there's a limitation. You can only draw alcohols. And the alcohol must have a formula of C4H10 and O. So how many alcohols can you make? And you have to make all the structural possible isomers and the stereoisomers. You have to take care of the stereoisomers as well. Send me the solution to this. C4H10O. How many alcohols can you make? You can try doing this. Try sending me the answer to this. You can remember an alcohol has an OH group. And it has to be C4H10 and O. So we'll leave it here and we'll continue with this in the next class. Okay?
Okay. Allah Hafiz.
Try sending me the
Yeah,
answer.
Allah Hafiz, sir.
Okay, take care. Allah Hafiz.
Okay, sir.